This is Parallel Lines and Transversals Part 2. In Part 1, we learned some new vocabulary words, and in Part 2, we're going to learn the theorems, or the math rules that go along with them. So, first of all, let's start with this picture. This is the picture we focused on in Part 1. It's two parallel lines, that's what you see in blue, and then what we call a transversal, which is the red line that crosses the two parallel lines. So our first vocab term from yesterday, or from Part 1, was corresponding angles. And we said you can imagine two groups of 4 angles here. Everywhere the red line crosses one of the blue lines, it makes 4 angles. And if you have the same position angle in each group of 4, we call those corresponding. So for example, this angle right here and this angle right here are corresponding angles. And I'll switch colors. Let's do yellow. We'll do green here. Let's do this one right here. This angle here and this angle here, the green ones. Maybe we'll do 2 markers for these. Those are corresponding angles also. And 1, 2, 3, 1, 2, 3. Those angles are corresponding also. And then the fourth one would be the one I haven't marked. That would be the last corresponding angle. And I can do 1, 2, 3, 4. We'll do yellow. 1, 2, 3, 4. So each color represents a pair of corresponding angles. The purple are corresponding, the green, the dark red, and the yellow. Now what we learned about these in Part 1, those are all equal. Those are congruent or equal. So the 2 purple angles there are congruent. The two that I mark with green, congruent. The 2 that I mark with the dark red, congruent. And the 2 that I mark with yellow, congruent. So that was a quick review of what we learned in Part 1. What we're going to do now is review our other vocab terms and learn a theorem that goes with it. So we learned about something called alternate interior angles. And remember, we said for each of the 2 words, the word alternate has to do with the transversal, and the word interior has to do with the parallel lines. So alternate means one from either side of the red line. We'll take one from the left and one from the right. And interior means we want both angles to be in between the blue lines. So you have 2 possibilities here. I could do this one here and this one here, or this one here and this one here. And that's it. Those are the only alternate interior angles on the picture. All right, so we learned that in Part 1. Here's what's new for today. We're going to learn a new theorem. Those angles are also congruent. So the 2 angles I marked in purple are congruent by the alternate interior angle theorem, and so are the 2 ones I marked in green. All right, let's keep going through the rest of our vocab from Part 1. We learned about alternate exterior angles. So alternate still means one from each side of the red line, but exterior means this time instead of in between the 2 blue lines, we want to be outside of them. So our 2 possibilities for alternate exterior angles could be here or here. I'm sorry, here and here, the 2 purple. And then here and here, the green ones. So it's the same as the alternate interior, except instead of being inside the lines, it's outside of the lines, the blue lines. So the theorem for this one, for the 3rd time in a row, those things are also congruent or equal. So those 2 purple angles that I marked are equal. Those 2 green angles that I marked are equal. So far corresponding, alternate interior, and alternate exterior angles are all congruent. They're all equal to each other. Let's keep going. Our next vocab phrase was same side interior angle. Now, same side is exactly what it sounds like. It's talking about the transversal. It means both angles are on the same side. They're not alternate this time. They're opposites. Same side. Now, interior means in between. So my same side interior angles could be here and here. See, that's on the same side of the red line. but it's interior on the inside of the blue lines, or it could be here and here. Now our rule for these, this is the new part for today, these are not equal. These are our first theorem that's not about two things being congruent or equal. Those two angles are supplementary, meaning they add up to 180. So the two angles that I marked in purple in this picture are not necessarily equal. In fact, when you look at them, one of them is acute, or less than 90, you can tell just by looking at it, and the other is obtuse, or greater than 90. So they're definitely not equal. What's special about them is that they will always add up to 180 degrees. So if I know one of those two angles, I can subtract from 180 to find the other. Now our last vocab phrase from yesterday, same side exterior angles. So by now we're getting used to these words, alternate, same side, interior, exterior. Same side means same side of the red line. Exterior means on the outsides of the blue lines. So your two possibilities this time are here and here, or here and here. Now the theorem for same side interior or same side exterior is the same as the theorem for same side interior. Those add up to 180 also. So basically we have 4 new rules or theorems today that you guys want to remember, and this is how we're going to use them. So once you've learned a theorem, that now becomes something that you can use as a reason in a proof. So remember, we've been spending a lot of time giving reasons for statements. We have given information, and then there's a statement, and you guys give the reason for that statement. And the reason is how you know it's true. Well, these 4 new theorems that we learned today are new reasons for those statements. So what you're going to do for today's assignment, I've written out some proofs and I've partially done them. I wrote all the statements. What you guys are going to do is go through, and for each statement, you guys are going to give the reason. Now the reasons can be anything we've learned. It can be the 4 theorems from today. It could be about corresponding angles that we learned in part 1. It could be the vertical angle theorem, the linear pair theorem, anything we've learned so far this year. But basically, once you learn a theorem, you can now use it as a reason in a proof.